Hello, this is Mr. Jolt here with your daily dose of GCSE maths, and let's get this going on. So basically we're going to be working on circle geometry today. We're just going to go through some basics, then we're going to look at some more complicated stuff. So first of all, let's just have a circle. So there's a circle, there is a perfect circle, such as we only get in physics and maths. We love perfect circles, but anyway, that's your circle. Now, around the outside of the circle, we have what's called a circumference. All right, that's your circumference. It's the thing that goes all the way around the outside of the circle. Basically, it's the perimeter of your circle. That, my friends, is a circumference, and don't you forget it. Now, we have a couple of other bits of circle that we need to know about. The first bit of circle we need to know about is the centre here, because a lot of stuff in a circle happens in relation to the centre. We're going to call this centre O in this case, because it's an O and it's a circle inside a circle. It's a meta circle. Isn't that awesome? Anyway, going away from that, we have what's called a radius. The radius goes from the centre of the circle out to the circumference. Doesn't matter in the slightest whereabouts on the circle it is. It's always a radius if it goes from the centre out to a circumference. That's a radius. That's a radius. And they are all radii. They're radii. So you have one forward focus, several forward foci. I think that's how it works. Anyway, what happens if you take a double radius? So you take two radii, and you put them end to end. So you have one radii going from one circumference to the centre, and then directly in line with that, you have another one. Well, what you have is a line that goes all the way from one circumference to another and passes through the centre, and that's called a diameter. So we've got these words here. We've got circumference, we've got radius, one radius, several radii, and we have diameter. All right? Circumference, radius, and diameter. And they're the first three things that we're going to kind of think about. You can use these to work out quite a lot to do with a circle. Actually, all you really need to work out a bunch of stuff in a circle to begin with is the radius. That's all you need. If you have the radius, you can actually work out what the area of a circle is. And you can also work out what the circumference of a circle is. You can work out what the diameter of a circle is as well, because diameter is just... diameter divided by 2 will give you a radius, because that's a diameter and that's a radius. So you have kind of two radii making up a diameter. Anyhow, let's think about exactly how you'd go about working out the area of a circle. Then we'll go to my website and take a little look at that. So here's your radius. So let's call our radius R. In order to work out what the circumference of a circle is, the circumference, that's the bit around the outside, it's very, very simple. It's just 2 pi r. Now, what's pi? Well, pi is just one of those really, really useful numbers that we use to work out a ton of stuff in a circle. That's all you need to know for now. And today we're going to be working with pi as if it were 3 points. So pi equals 3.14159. That's as far as we're going to go. You can go further. 3.1415926535898. 7, 9. You can take it a lot further than that, but there's no need to. That's what we're going to be using at the moment. So let's say, for example, that we have a radius of 2 centimeters. Let's say 2 centimeters. That's not 2 centimeters, but we'll treat it as if it is. And to work out the circumference, we would go 2 pi r, which means we'd be saying 2 times 3.14. Let's just call it 3.14 because that's easier to work with. Times the radius, which is 2. Now, I'm going to give a rough answer here because I can't work this out in my head. 2 times 2 is 4, and 4 times 3.14 is going to be 4 times 3.14 is going to be about 13-ish centimeters. So it's going to be 13-ish centimeters. So it gives you a rough idea. Let's go and draw on the knowledge of Python right here. We're going to get a let's get a Python terminal up to use as a calculator, and let's make it a little bit bigger actually so we can see things. That'd be nice. There you go. So make it a little bit larger so we can see what we're doing here. Let's have it up to 20. There we go. All right, apply. Okay, and so we've got 2 times 3.14. All right. And that's 12.56. So if you round that up, that's close enough. But the answer is actually 12.56. I was pretty close. And so that's how that works. You can also work out the area. So the area of a circle. And assuming we've got the same radius, the area is going to be pi times the radius squared. Now this squared thing, no need to be afraid of that. Squared literally just means times itself. So that basically means you've got 3.14, because that's pi, times the radius squared. So times 2 squared, or you could also say times 2 times 2. And that's interesting. So in this situation, we actually end up with this situation. It actually looks remarkably similar to this, doesn't it, up here? So actually we're going to end up with pretty much the same answer on this occasion. It's going to be 12.56, which is what we got just now when we used Python to work out the answer. By the way, if you're interested in Python, go over to DevJolt. It's where I developed the website, which I'm going to be showing you today. So, having been through those basics there, let's now go across to here. Let's get something up, shall we? Let's get a new. There we go. Let's get a new window up, and if we go to just.jolt.pythonanywhere.com, that's the website I'm currently developing for the purpose of learning all kinds of wonderful stuff. If we go just here, geometry and measures, and let's go to circle geometry, area sets and volumes, area of circles, and let's just test our knowledge of this, shall we? So, on the diagram above, what does B represent? Well, B is this thing here. And B, on this occasion, I think we'd all be fairly confident in saying represents the radius. And indeed, when we click on the answer there, it does represent the radius. This, by the way, is kind of a level 2 sort of thing to know. It's kind of only a level 2 thing to know. So it's not so, you don't have to be that high up to know this stuff. Just being able to name these is great, but anyway. What does C represent? Well, C, of course, it's not the circumference, which it probably will be in most of your exam papers. C in this case represents the diameter, so it's a line that goes from one end of the circumference to the other, but through the centre. That's the important thing, through the centre. So that's the circumference. Click on the answer, it'll tell you it's the diameter, sorry. And then finally, what does B represent? We already know that's the radius. What letter represents the diameter? Oh, this is a bit of a different one. So the C represents the diameter here. Yep, got that right. Which letter represents the diameter? It had the same again. Oh my goodness, randomness is not working. So which letter represents the radius? It's going to be B. Anyway, I think we pretty much got the hang of this type of question. Let's move on to another one. So what's the formula for the area of a sector? Well, this isn't something that we've dealt with yet, because we need to know exactly what a sector is. So how about we do this? How about we scrub out some of the stuff on this circle, and how about we work out what a sector is? Because this is now a new piece of terminology. There you go. So we've rubbed that off there. We've got our centre here. Now let's go ahead and let's take a radius. There's one radius. Well, what happens if we put another radius in somewhere? Well, there's two radii right there. Two radii. There can be an angle between these two radii. There can also be an angle right here. There can also be kind of an exterior angle of these radii, if you like. But anyway, there are two radii, and this area in here is what's known as a sector. So the area of this thing here is what this particular question is asking for. Anyway, so that's a sector. Actually, that's a sector as well. And this is a smaller sector, so it's known as a minor sector. And this is known as a major sector because it's bigger. Now, before we move on and answer that question, there's a couple of other things that I want to deal with, because because as well as dividing up the insides, these two radii here and this angle which kind of represents them also divides up our circumference. So you'll notice here that our circumference, if we wanted to, we could take this part of the circumference here. Oh, there we go. And there's also a part of the circumference there. Now, these parts of the circumference which are divided up are known as arcs. And again, you have a minor arc and a major arc. Anyway, we're going to get back to the question now. We're going to be dealing with that a little bit later. Let's just pick that up. So how do we work out the area of a sector? Well, we can do that using this angle here. So when you draw these two radii, they're going to create an angle. And let's say that angle, as far as we're concerned, is going to be theta. Let's call it theta. Theta is just a funky Greek letter that looks like this. You can't quite see it there because it's too small. Basically, it looks like an Easter egg, which is why we're going to use it. So anyway, that's theta. So there's theta. And how are we going to use theta to calculate the area of this sector here, this part of the circle? Well, a circle is made up of 360 degrees. Okay, and the area here, I guess then, this angle is a kind of a proportion, if you like, of that 360 degrees. So if you take that angle, which we said is this Easter egg theta right here, and divide it by 360 degrees, you're going to get kind of a proportion. You could turn this into a percentage if you wanted. If you wanted to, you could turn this into a percentage, work out the whole area of the circle, knowing R, of course, and then you could well, let's just do that, shall we? Let's say that our radius here is 2 centimeters, and so the whole area of the circle, is going to be what did we say it was going to be earlier? It was pi r squared, wasn't it? So the area in this case we worked out earlier is 12.56 centimeters. Whoops, centimeters squared is the whole area. Right. So, but we don't want the whole area. We just want the area of this thing here, this sector, this slice of the circle, which is a sector. This sector, and so the proportion of the circle that is this is going to be that divided by 360. Are we agreed on that? So let's say that this angle here is oh, I don't know. Let's say that the angle is 70, because that's going to get us a lovely answer there. So 70 divided by 360, that's going to get us the kind of the proportion. It's not a ratio, but it's going to get us the proportion of the circle that is. So 70 divided by 360. Again, without using a calculator, we're just going to go back to Python here and do this. This isn't the only thing that you'd use Python for, by the way. You use Python for a lot of other more useful stuff than that. Anyhow, let's have a look at this. Let's go for what do we say? 70 divided by 360. There we go, which gets us a wonderful number, and we're going to round that. 0.194. We'll just call that 0.194 for now. Well, if we were to multiply that then by 100, then this would be 19.4% of that whole circle, this bit. And so if we know the whole area, then we just need to find 19.4% of this. And how would we do that? Well, we would do that by multiplying this by that. This by that. So let's just get rid of this. 70 over 360 times the area, which is 12.56, which is going to be equal to, and let's go back to Python to help us with that again. So let's have 0.194 multiplied by 12.56. And so our answer for that is going to be 2.4, let's call it 2.44, let's round it. So equals 2.44 centimeters squared. All right. Now, what I'm going to do now is let's generalize this a little bit, shall we? Let's generalize. So, in terms of working out the area of a sector, what we've got is we've got this Easter egg theta divided by 360. We could call it x if we wanted to call the Easter egg x. We could do, but it's Easter, so let's use the Easter egg looking thing and call it theta. Times, and what was this? This was the area of the whole circle. And that will give us the area of our sector. Let's go back to the website and let's see if that's the case, shall we? So let's go back here again. So what's the formula for the area of a sector? And if I've programmed this correctly, oh no, good heavens! Oh, it went away. I pressed the wrong thing. There it is again. And what we've got is the sector angle divided by 360 times the area of the circle. All right, and that's the formula we would use. Let's have a look at another one of these. The following formula will find the area for what? Sector angle divided by 360 times the area of a circle. Obviously, the answer to that is going to be the area of a sector. What's the formula for the length of an arc? Now, let's go back to our diagram here. And we've got this thing here, which is the circumference. And our two radii chopped off a bit of our circle. But not only did it do that, it also divided up our circumference. If we kind of carry these on, we can see that we've also divided up our circumference into bits as well. Well, the good news for us is that the formula for the area of a sector is actually really, really similar to the formula for the length of an arc. So let's go back and let's take a look at this here. So just there we had 70, which is this angle here, divided by 360 times the area of our circle. Well, we don't want the area of a sector anymore. We want the length of an arc. So we want to know what proportion of our circumference is included in this kind of angle here between these two radii. So that being the case, let's get rid of this. We don't want the Easter egg divided by 360 times the area of the whole circle anymore. Now we want to multiply the length of the circumference. So we got the Easter egg divided by 360 to get that kind of proportion, that proportion of the circle we're interested in, times the circumference this time. And that should get us the length of this arc. It'll get us the length of the minor arc. If you wanted to work out the length of the major arc, then you would take this angle here, which 360 minus 70 would be 290 degrees there. But we don't want that. We want this bit here. So let's try that, shall we? So let's have our Easter egg, which is 70 in this case, divided by 360 times our circumference. How did we work out circumference before? Well, we worked out circumference before, hoping my microphone's on right now, by going 2 pi r. Now we know that that's 2 centimeters, and we know that that's going to be 12.56, which is great. So let's now do that calculation. Well, actually, do we even need to do the calculation? Because it's going to be the same answer as before. So if we go back to Python once more, go back there. So we've got our proportion right there, which is going to be the same as before, times 12.56 equals 2.43, and then let's just round that, equals 2.44 centimeters. Is it centimeters squared this time? It's not centimeters squared this time because it's a circumference. And so that's your formula. That's your basic formula. So you've got the angle of the arc divided by 360 multiplied by your circumference. And again, let's go back to the website and just see if that's the answer it was looking for. I sure hope it was, because that's how I programmed it. There we go. Look at that. Isn't that wonderful? Isn't that wonderful? Okay, a formula for the area of the circle. We know that's going to be pi r squared. There it is. Brilliant. The following formula will find the area for what? 2 pi r or pi d? Well, hang on a second. That's two completely different formulas, isn't it? Let's just go back to our little board here. What did it say? 2 pi I or pi d? They're two completely different formulas. How on earth could they be calculating the same thing? So let's have 2 pi r or pi d. Well, r is a radius, right? Which is one of these. And d is a diameter, which is from one end to the other. And so is it fair to say that this is going to be the same length as that? Well, yes, it is, because they're both radii, and all the radii in a perfect circle are going to be the same. So instead of saying two radiuses, you're just as well saying diameter. So that's the same thing. And what do both of these equal? Well, it's nothing squared, so it's not going to be area. It's going to be the circumference, isn't it? Circumference. That's what I think anyway. So let's go back to the website and let's see what happens. So circumference. There we go. Is that the answer they wanted? The circumference of a circle. Wonderful. Let's close this window and let's take a look. So, area of a circle questions. Let's do a couple of these. So on the diagram, C equals 14 centimeters. Find the area. Well, let's do this then. So on the diagram, C equals 14 centimeters. Let's find the area. So I'm just gonna scrub this off the board here. We've got a new circle, and C, which is the diameter, is equal to 14 centimeters, and we've got to find the area. So the first thing I'm going to do in this case is I'm going to write the formula for the area. That's the best, most wonderful thing you can do to begin with. So the area equals pi r squared. So that's going to equal 3.14. Remember, we're going to treat pi as 3.1415, whatever, but we're going to treat it as 3.14 times the rate. Oh my goodness, we don't have a radius. What are we going to do about this? All we've got is a diameter. Well, you remember, a diameter is kind of twice a radius, so we can work out the radius quite easily, actually. So the radius in this case is going to be 14 divided by 2, so it's going to be 7. All right, and 7 squared times 7 squared. So let's just take a look at this, and that's the same as saying 3.14 times 7 squared, which is 49. So let's go ahead and let's use our calculator. So I'm just using Python here as a calculator. You can, just because that's what I do, 3.14 times 49. And the answer there is 153.86. So let's go to 2 decimal places. Equals 153. Does it say 153? Yeah, 0.86. What are our units? Well, it's area, so our units are going to be centimetres squared. So there's our units. Let's go back to the website now and just see if I've programmed it well enough to get the right answer. And you can just use this website for free, by the way, if you want to revise GCSE Maths. There we go, and we've got the answer being 153.94 centimetres squared. And why is that different? Why is there a difference there? Well, there's a difference there because I should imagine my programs probably use pi to however many decimal places it's allowed to be used. There we go. But the answer, actually, if you were to round this, you get the same answer, and the answer would be correct in an exam situation as far as you're concerned. So there we go. Let's not bother with well, yeah, go on. Let's have another one of those questions because they're actually quite easy. So B in this case, it tells us is 5 centimetres. So that's B, so that's the radius in this case, is 5 centimetres. Let's get rid of the 14 centimetres that was there before. So there's our new question. So we want to work out the area of a circle. And this time we've got B as 5 centimetres. Well, this time there's no need for any complicated maths to happen in terms of finding the radius, because we've told what the radius is. Times 5 squared equals pi times 25 equals, and let's go ahead and let's calculate that. You should use a calculator for doing this, but I'm using this just because it's right there. I can just type this in. So 159 times 25, and we've got 78, and let's round that, 78.54. And now let's see if that's the same answer as we got on the website there, 78.54. Yeah, and that's exactly the same. I made a mistake actually. I didn't write centimetres squared, so I would have possibly been penalised for that if they didn't provide that for you anyway. Right, so we're actually going to skip one of these question types here. We've got circumference of a circle. I'm not actually going to bother with that because that's actually easier even than working out the area, I think, because you're just using a different formula. So let's move on to something that's a little bit more complicated now. We've got arcs and sectors, so let's move on to that. So on the diagram above, which letter represents the minor arc? And there's quite a lot of stuff going on here. How did I get there, by the way? I just clicked. I clicked on there, arcs and sectors. There we go. So what does B represent? As it happens, B represents a minor arc. So an arc is a part of a circumference. You've got the small part of the arc and the big part of the arc around the outside there. And the small part of the arc here is called the minor arc. So the answer to here is going to be B. If you wanted a little help with any of these questions, you could get them, but no need. Let's have a look at B. There you go. So you've got a minor arc there. Let's do another one of these. Which letter represents the major arc? Well, obviously that's going to be A. Completely randomized questions. So the answer there is going to be A. Let's have another one. On the diagram above, what does D represent? D, well, that's this area here. Now, if you remember, if you divide a circle up using radii, then you end up with sectors, and you have a smaller sector, which is known as a minor sector, and a larger sector, which is known as your major sector. So D is going to be a major sector. There's your major sector there. Let's have another one. Which letter represents the angle of the major sector? Well, it's not going to be X, because X is the smaller angle. It's going to be Y, because Y is the larger angle there. So there's your major sector. It's going to be Y. Let's take one more. On the diagram above, which letter represents the major arc? Well, that's A. We've already done that. Anyway, you get the idea. You can use this to practice. Segments. Oh, there's a new thing. There's a new thing entirely. Well, now we're introducing something else into the circle here. So let's go back to our whiteboard and let's take a look at some of the new bits of a circle. So there's my perfect circle right there. Absolutely spectacular. There's the center of our circle again. And let's draw two radii. Now, if you're familiar with circle geometry, there's another thing in a circle. Now, arguably, we've already come across this type of thing. You know how a diameter goes from one end of the circumference to the other and it passes through the middle? Well, what would happen if you had a line which went from one circumference to another, but didn't pass straight through the middle? What would happen then? Would it still be a diameter? What's that? So you're going from one circumference to another, one part of the circumference to another, hits the circumference to 2 points, but it doesn't pass through the center. What on earth is that called? Because it's not a diameter anymore. It's certainly not, because it's not passing through the middle. What's it called? Well, for some reason, it's called a chord. So this line right here is called a chord. The same as the chord on a guitar. It's that. If it doesn't pass straight through the middle, it would be a diameter if it did. It's called a chord. And so what happens then if we make that chord hit the circumference at exactly the same place as these radii here? So that's a radius. That's a radius. This is a chord. And this area here, this area right here, that is kind of sliced off the circle, it kind of looks like it's kind of part of a Terry's chocolate orange, doesn't it? And that's good because it's actually called a segment. That's called a segment. So when you draw a chord and you kind of slice a bit off of your circle like that, that's called a segment. If you do the same thing with a diameter, you just end up with a half a circle. So that's not a chord, that's just a half. That's not a segment, sorry, that's just a half. Anyway, on the diagram above, what does E represent in this case? So let's see what we've got here. There's your radius, there's another radius, there's an angle of the two radii, and E is green, and there's E right there. So that's your chord. That's a chord right there. Generate another question. In the diagram above, what does F represent? Well, you've got E right there slicing off this bit, and what do we call that? Segment. So the answer we should get right here is segment. So let's see if that's the answer we get. Yep, segment. There we go. Let's just take one more. Can't imagine that too much more stuff is going to come up. What does R represent? Obviously, that's going to be a radius. And all of this stuff until now has really only been level 3 stuff, because remembering stuff like this isn't difficult. Let's do some level 6 stuff now. Let's actually go ahead and find the areas of some of these things. So on the diagram above, which is not to scale, there it is. X equals 54. They're calling it X instead of theta because they're not very Eastery. X equals 54. So let's write that in there. 54. There we go. And what else does it say? The area of the circle, the whole area of the circle, area is 21 centimeters squared. And it wants us to find the area of the minor sector. So there is our minor sector. All right, right there. Can't even see it. There's our minor sector. Okay, and that's what we're trying to find. The area of the minor sector. So let's just remind ourselves what that is. Area AMS I'm going to write for area of minor sector just to save me time. What did we say that was? Well, we've got the whole circle, and the area of this is going to be the whole area of the circle minus the major sector, or we could also say it's going to be the area of the circle, but it's only the proportion of that area that's in here. So how are we going to find how are we going to find that proportion? Well, we have 360 degrees in a circle, and 54 degrees in x right here, divided by 360 is going to give us that proportion. And if we multiply the whole area of the circle by that, that should give us our answer. So we already know what the area is. We haven't got to calculate it. So times 21, and that should give us our answer. So now I'm going to go ahead and I'm going to calculate that. So you should do this on a calculator. You can go ahead and use idle if you've got it. So we've got 54 divided by 360 times 21. And the answer we get there is 3.15. Does that look right? Divided by 360 times 3.15. Yeah, that sounds like it could be just about kosher. Right, so 3.15 is our answer. Let's see if that's the same answer as what we get. The answer, by the way, should be 3.15 centimeters squared. And we get 3.15 centimeters squared. Not going to bother doing another one of these. We're going to move on to the length of an arc now. So on the diagram, not to scale, again, x is 153 degrees. Obviously, that's not to scale. We're just going to swap this out. 153 degrees. And the circumference of the circle, we're not dealing with area anymore, we're dealing with circumference. The circumference is 28 centimeters. So there's the circumference, and we want to find the minor arc's length. The minor arc's length. So that means that we want to find the length of this. This angle is 153 degrees. The circumference is 28, and we want to find the minor arc's length. So again, this is a level 6 question because you're having to kind of separate this major minor arc thing out, but also it's a bit more of a complicated thing. So first thing we need to do is work out what proportion of the circumference this is going to be. Well, that's quite easy again. Let's say let's call this the length of the arc is going to be 153 divided by 360 multiplied by the circumference. So for a level 6 question, it's actually quite easy. It's just remembering what you need to do. So 153 divided by 360 times 28. Let's go ahead and let's calculate that now. So again, I'm doing the calculations here. So you got 153 divided by 360 to get the proportion of the whole circumference that we want, and then multiplied by the total circumference is going to be 28. So our answer is going to be 11.9 centimeters. And let's just see if that's the same answer as we get here, 11.9 centimeters. Let's move on to our next question types.